Welcome, everyone. For today's prep, we're going to continue on with our limit laws. And the ones that we started looking at in class ultimately are going to lead us to these two special laws that are really going to simplify the process for how we calculate limits. And the first one here is when our function is a polynomial. So if we're calculating the limit as x approaches a of a polynomial. Now, what's a polynomial? Well, let's write down a little example. These are the things that we're going to be working with. So, like a quadratic. X squared plus 5x minus 6. That's an example of a polynomial. So if we're doing the limit of a polynomial, we'll generally just call this p of x as x approaches a. Well, all we have to do to calculate that limit is to just plug in the number x is approaching into our function. So if x is approaching a, we're just going to plug that into our function. And when we do that, we're going to call this direct evaluation. So all we're doing to calculate the limit of a polynomial is we're just going to plug in the number that x is approaching. Now, another type of function that we're going to consider is a rational function. Now, a rational function is when we take a polynomial and we divide it by another polynomial. So this is when we have kind of like a fraction. So, as like a rational function. What might that look like? Well, maybe we take x squared plus 5x minus 6, and then we're dividing it by x plus 2. That's an example of a rational function. So it's a polynomial on the top divided by another polynomial on the bottom there. Okay, so we've got those two polynomials. Well, how do we calculate the limit of a rational function like that, a fraction? Well, as x is approaching a, all we have to do is, again, just plug in. So we plug the number x is approaching into the top polynomial, and we plug it into the bottom polynomial. Now, the tricky thing with rational functions is we have division, and we have to be careful. When we plug into the denominator, we can't get 0. If we get 0, then something else, we have to do something else. So if we get a 0 down here, we gotta be careful. If this is not 0, then perfectly good. And in each of these cases, we're going to call this step direct evaluation. So the limit, you want to think of this limit sign, it's like a question. It's asking you, what is this function doing as our input value gets close to this number a? So this is kind of asking you, where is our function going? And what direct evaluation tells us is it tells us where we're going. It's going to this value, kind of like what we would expect. Now, there's going to be rational functions, though, where it's not so obvious. And that's what we're going to look at. We're going to see what happens if we divide by 0. And the main thing we're going to see is there's other cases, but the one we're going to look at a bit is we want to watch out for, when we do direct evaluation, 0 over 0. So we got to be careful with that. And our first example is going to show us what to do. All right, so x is approaching 3. We're going to do the limit as x approaches 3. And our function here is x squared minus 9 over x minus 3. So the first thing we want to do is we're just going to try. This is a rational function. So we have a polynomial on the top. We have a polynomial on the bottom. So we're going to try direct evaluation. It's always a nice. When it works, it's really nice. So all we're going to do is we're going to take that input value, we want to get close to 3. So let's see what happens directly at 3. We're going to plug it into our function. So when we do that, we get 3 squared minus 9 over 3 minus 3, which simplifies to 9 minus 9 over 3 minus 3, which ends up being 0 over 0. And that's no good. So this is what we were talking about with these rational functions. Sometimes we end up with division by 0. And the idea is if we do run into that, what the 0 on the top here is telling us, and what the 0 on the bottom here is telling us, is that there is a factor, there is the same factor on the top and the same factor on the bottom here that we can cancel out and kind of get rid of. So we're going to retry this. But factor first. And then we're going to cancel. All right, so let's try this again. We've got our limit here that we're trying to do. And what we want to factor this numerator. Well, you want to factor both. Sometimes the denominator's kind of complicated and we got to factor down there. But in this case, that's about as simplified as we could factor that. It's only one factor. But when it's a quadratic, that's an indication that there might be 2 factors that we can do. So we want to try to factor this. And it factors nicely. So it factors into x minus 3 times x plus 3. So look at that. And we can check that. So if I multiply this x with that x there, I get the x squared. If I multiply the negative 3 with the x, I get negative 3x. And then if I multiply the positive 3, negative 3 with the x, I get negative 3x. Then if I multiply the x with the positive 3, I get positive 3x. So those cancel. And then when I do the minus 3 and the plus 3, I get negative 9. So you can try kind of checking that out. Whenever you factor, if you're a little uncertain, just kind of do it off to the side and just double check it. So if I multiply the x's together, that's going to give me the x squared. If I multiply the x with the plus 3, I get plus 3x. And then the negative 3 with the x, I get negative 3x. And we can see those cancel. And then the minus 3 with the plus 3. And that ends up being minus 9. So if I multiply this back out, I go backwards. Just kind of like a check. So it doesn't hurt to do that. All right, so in any case, we've factored the numerator, we've factored the denominator, and now you might be noticing that we have an x minus 3 and an x minus 3. One on the top, one on the bottom. We can cancel those out. So the idea here is we factor, then we cancel, and once we've done that, now we've gotten rid of that piece in the denominator that was giving us 0. So now we retry our direct evaluation with this simpler version. So let's see what we get. So x is approaching 3. Now our function is just x plus 3. So direct evaluation tells we just plug in. So we end up with 3 plus 3 here. And when we do that, we end up with 6. And that's our limit. So this is the idea for rational functions and polynomials. Try direct evaluation first. A lot of times it'll work, and you're done. If it doesn't work, well then we retry it, but with factoring and cancel. So you want to try to factor the numerator and denominator as much as you can. And then because we got that 0 over 0, there should be factors on both the top and the bottom that match up, so you can cancel those out. And then as soon as you do that canceling step, take the simplified version of the function here and just try direct evaluation again. And it should work out. Maybe there's other things you have to factor, but ultimately we can get down there. All right, so we're going to try another few examples of this in class. So we'll see you then. Bye-bye.